Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to talk about engine diagnosis. We are going to analyze inboard engines, troubleshooting in inboard engines. And in particular, today we are going to analyze black smoke. We are going to check blue smoke. And of course, white smoke. What happens when you have that situation? Black smoke, blue smoke, or white smoke. This is a special analysis because this is for marine engines. And remember, in marine engines, instead of the radiator that you have in your car, we have a heat exchanger. The rest is the same, but we need to take in consideration that situation. Okay, we are going to check the tools that we are going to use in this diagnosis. Okay, the tool number one is the service manual. The service manual of the engine. Try to get the service manual. Number one. Number two, the poster for the oil sample analysis. That's an important poster. Number three, the poster for the coolant sample analysis. And number four, the poster for the OBD2 codes analysis. The analysis of the codes. Those three wonderful posters, you can get those posters in my website www.mrlopezclasses.com. Okay? Also, you need a good multimeter and an infrared laser temperature gun. Those tools are necessary in order to get good diagnosis. Okay, guys, we are going to start with the first one, with the black smoke. What happens when you have black smoke in your engine? Guys, don't forget that black smoke is basically related with a rich mixture. You remember the stoichiometric ratio? Yes, that's the ratio in between the amount of air and the amount of fuel. How many portions of fuel you need to burn that amount of air. In gasoline, the stoichiometric ratio is around 14.7 to 1. This is in ideal situation at sea level, but in the real life is around 12 to 1 in gasoline engines. In diesel, fluctuate. Depend on the altitude and depend if the engine is naturally aspirated or if the engine is turbocharged. But the stoichiometric ratio is completely different. It's in between 21 to 1 until 70 in regular conditions, 70% of air to 1% of fuel. Or, if the engine is supercharged, it's 160 to 1. That's the difference between gasoline and diesel. That's why a diesel engine is more efficient than a gasoline engine. It's simple. That equation explains easily why it's more efficient. Remember that an engine, good definition for an engine, gas or diesel, is an equipment designed to burn air. Yes, my friend, burn air, not fuel. The people think, oh, my engine burns fuel. No. Your engine uses that type of fuel to burn air. Oh, the gasoline engine uses gasoline to burn air. The diesel engine uses diesel to burn air. The alcohol engine uses alcohol to burn air. Yeah, that's the fuel to burn the air. What engine is more efficient? The engine that burns the maximum amount of air with less fuel. Gasoline, only 14.5 to 1. Diesel, 70 to 1 or 160 to 1 is more efficient. In different terms, later in other episodes, you can check a lot of episodes in my website www.mrlopezclasses.com, and you go to the section videos and you select million of videos. There are a lot of videos where I explain the terms of efficiency. Okay, rich mixture. We are going to be concentrated in the rich mixture. Rich mixture is a lot of fuel, more fuel than air in that equation. Remember that the engine is intelligent, and when you reduce the amount of air, the engine compensates with more fuel. Yeah, that's the problem. What is the symptom when you have a rich mixture, of course, is black smoke, a lot of black smoke. We are going to start checking what happened in that particular situation. What is the problem? Where will be located the problem? Probably the injectors are working improperly. The injectors don't close properly, and some leaks of fuel constantly fill the combustion chamber. And of course, in the moment of the explosion, you have black smoke because you have excessive amount of fuel in that area, in the combustion chamber. That's number one, injectors. You need remove the injectors, calibrate the injectors, send the injectors to the matching shop, or do the service in the injectors like I explained in the videos of my courses, gas and diesel. Okay, number two for diesel engines, bad fuel injection pump. Yeah, it's not common, but in some cases, overpressure in the fuel injection pump destroy the injectors and produce constant ingress of fuel in the combustion chamber. Overpressure in the fuel injection pump. For that reason, my friend, both of them, injectors and fuel injection pump, should be calibrated periodically according with the intervals recommended in the service manual. This is very, very important. Each manufacturer have a different windows times for those services. Follow the service manual. Okay, other possibility is bad fuel. Of course, there are fuels of with too much level of sulfur, too much level of phosphorus. Yeah, bad fuel is other source. Is less, but is other source for this problem, black smoke. Okay, other possibility is a failure in the turbocharger. Why the turbo can affect the performance of my engine, especially in that situation, black smoke? Yes, my friend, remember that what happened if the turbo suction less air for different reasons, because the turbine is broken, because it's locked, the turbine, or the filter is clogged, different options. The amount of air entering in the cold side of the turbo is less. Of course, you have less air in the combustion chamber and more fuel, and of course, at the end of the day, you have black smoke. Yes, if you have a problem on the turbo, probably this is one of the possibilities for black smoke. Check the blade with your finger. Try to rotate the blade in the turbine in the cold side with your finger. Should be free. Try to check that no lateral play. I explained that procedure in my chapter 15 in the course of diesel engines. Okay, check the condition of the turbocharger. This is one possibility. Okay, other possibility, of course, is fuel contaminated. Other one is clogged air filter. Yes, my friends, the air filter clogged, less amount of air, and the engine compensates with more fuel and black smoke. Other possibility is a malfunction of the MAP sensor, manifold absolute pressure sensor. If you remember that in the intake manifold you have vacuum, you have suction, and that sensor sends the pressure, the negative pressure on that manifold. If that sensor is erratic, if the signal is not good, the engine compensates with more fuel. That sensor sends the signal to the computer, and the computer, with other parameters coming from the oxygen sensor, the throttle position sensor, and the temperature sensor, send the information to the fuel injection pump, to the fuel system, to introduce more fuel or less fuel. That's nice, no? This is a complete diagram. Okay, problem with the MAP sensor. In that case, you need to check your the OBD2 codes and verify what is the procedure to solve that particular problem with the MAP sensor, the procedure to do the troubleshooting with the MAP sensor. I explained that procedure in my course of gasolines in the section of sensors and OBD2 codes. Okay, guys, other possibility is the MAP sensor, manifold absolute flow sensor. Manifold absolute flow sensor. Okay, that sensor senses the amount of air entering in the combustion chamber. This is the most important for rich mixture, the MAP sensor. Okay, other possibility is the oxygen sensor, bad oxygen sensor. Remember that the oxygen sensor sends the amount of oxygen in the exhaust gases. According with the amount of oxygen, the oxygen sensor sends signal to the computer, and the computer compensates with more air, more fuel, less fuel, working together with the throttle position sensor and other sensors like a temperature sensors. Okay? Great, no? MAF sensor. Verify, once again, the troubleshooting on those sensors in that poster, the poster of the troubleshooting for codes, OBD2 codes. Other possibility is leaks in the intake manifold. Intake manifold, vacuum, air, suction. If you have leaks over there, the vacuum is not enough. The amount of air entering in the combustion chamber is not appropriated. And at the end, the engine compensates with more fuel, and the mixture will be rich, and at the end, the smoke is black smoke. Excessive amount of fuel. Okay, guys, I think that this is the last one. Problems in the computer, the ECM, the control module, problem with the control module. That's a possibility. When you check the sensors, if you found that the majority of the sensors receive less reference voltage from the computer, probably the computer have a problem. In that case, you need to check the computer. Normally, when I have boats with double engines, I switch the computer. And I verify if the problem is solved when I switch the computer, and bingo, this is the solution, the computer. Okay, guys, we are going to check the next one. The next one is blue smoke. My friends, blue is basically oil, burned oil. Excessive amount of oil in the combustion chamber. And we are going to check how can I introduce more or less oil in the combustion chamber. What is the procedure? Okay, of course, my friends, you need a compression test. You need to do the compression test to evaluate what happened with the engine. If the problems are the piston rings, or if the problems are the valves, or if the problem is the head gasket. You remember I explained in a video that procedure, how to check the compression in an engine, and the procedure to diagnosis if the problem is only in one cylinder, in two cylinders, or in the head gasket, or all the cylinders. The compression test is the most important. Okay, and also I recommend take an oil sample and use the brochure for the oil sample analysis. Those are the tools that we need to analyze the phenomenon of blue smoke. Okay. Possibilities: bad head valve seals. The seals. You remember those seals? The seals on the head valves? Yes. If those seals are broken or damaged, the oil penetrates in between the valve and the valve guide, and the oil enters in the combustion chamber, and immediately you have burned oil. This is one possibility. Of course, other possibility is that the valve guides are where you have a lot of play in between both of them, and the oil penetrates. That's other possibility. In general, it's a possibility. The oil in the combustion chamber is a problem in the head. That's the problem. Other possibility is piston rings broken. Okay, I think that is the less possible, especially in diesel engines with the 3 compression rings on top, 1 oil controller ring in the bottom. This is the function of the bottom. That oil ring, piston ring, is return the oil into the oil pan. That oil controller ring avoid that the oil pass to the other three piston rings, compression rings. For that reason, I think that it's difficult that if I have a problem with the piston ring, of course, if all of them are broken, the oil pass. That's clear. But in general, when I have wear piston rings, I have low compression. But no oil entering in the combustion chamber, because the piston, the oil controller, the bottom one, help to return the oil in the oil pan. Okay, but this is other possibility, the piston rings. And you know, with the compression test, it's clear that the problem is identified in the piston rings or in the head. It's easy when you remember when you added a little amount of oil in the combustion chamber with a low compression, and you test again if the compression increased. This is an indication that the piston rings are damaged, are wear or broken. Okay, this is the other possibility. The other one is problem with the head gasket. Yes, if the head gasket is blown or is broken, the oil enter in the combustion chamber or coolant. We are going to check later. That's the other possibility, problem with the head gasket. Another possibility is on the turbo, the seals on the turbo. You remember the turbo? And you remember those seals in each side of the shaft of the turbo? Okay, if the seal in the cold side where the air filter is located, of course, when the turbo is running, suction air enter, but enter with oil because the seal is broken. And that air pressurized with oil enter in the combustion chamber and produce blue smoke. Yes, it's very, very common problem on the seals of the turbo. Once again, check the recommendation, the intervals of service recommended for the manufacturer in the service manual. Use the service manual, do the service on the turbo according with those recommendations, and you don't have problems. Okay, problems on the turbo for blue smoke. Okay, we are going to analyze the last one, white smoke. This is, in my opinion, the most critical of those symptoms. White smoke is critical. You have a normally white smoke if humidity, if moisture, if water is entering in the combustion chamber. The problem here is because this is a boat, and in the boat we have two possibilities for humidity, water in the combustion chamber. One possibility is coolant, and the other possibility is salt water. What is more catastrophic? Yes, salt water is more catastrophic. Yes, my friend. Okay, if it's coolant, we are going to analyze, and if it's salt water, also we are going to check what happened. But we are going to, in order to isolate the problem, is coolant or is salt water, we need to check some elements. Okay, of course, we need a coolant sample analysis. Take a sample of coolant, send to the laboratory, and use the poster to analyze the element, what happens if I have excessive amount of phosphorus or sulfur or sodium or calcium or fluorine or, or chlorine. Those elements indicate that you have a contamination of salt water, contamination of excessive amount of additives in the coolant. I explained that analysis in details in the video of the coolant sample analysis, that video. Check that video, and you can follow that recommendation. Okay, you need a coolant sample analysis, and you need the report, and you need the poster to analyze what happened with the coolant sample report. Okay, number one, we are going to isolate the problem. Is on the coolant side or is in the salt water side? Remember that the cooling system in marine engines is divided in coolant and salt water. Okay, all right. Check the oil pressure. That's the number one. In the pilot helm, with the engine running, check the oil pressure. The oil pressure goes dramatically down. My friends, your oil is milky. Your oil is mixed with water. Okay, number two, check the color of the oil. Remove the dipstick and check what happened with my oil. Oh, my oil is milky oil. Wow, I have problems. You need to stop the engine immediately and not run the engine again until you solve the problem. Okay, and now we are going to check if the problem in the oil is coolant or is salt water. All right. I recommend to clarify that situation a little is in the expansion tank, remove the pressure cap or radiator cap and verify if you have oil in the coolant, and also if you see calcium around the gasket of the cap. In both cases, in the expansion tank and in the reservoir. In the reservoir you can see if you have calcium around the cap, is an indication that the salt water is mixed with the coolant. Okay, all right, and also we are going to check if we have the fuel contaminated with water. Yes, check the Raykor-Parker filters and verify that you don't have sediments in the crystal, in the ball of the water separator filter, and verify that you don't have water. If you have water over there and the elements, the filtration elements in the filters are damaged, probably fuel with humidity is entering in the combustion chamber and is producing that situation. Okay, other possibility is a clogged air filter. Remember that the air filter, there are two types of air filters. You remember that slide? Is dry air filters and wet air filters. The wet air filters, you can clean those filters with fresh water, and but in some cases you feel that the filter is dry, but internally in the other layers, the internal layers have a lot of humidity. When you put them back, those filters, a lot of humidity enter in the combustion chamber and produce white smoke. Yeah, this is other possibility on the air filters. Other possibility is a problem in the intercooler. Let me explain something about that situation. Remember that you have the possibility that the salt water enter in the combustion chamber. How many options are for salt water entering in the combustion chamber? Three options. The option number one is when you cranking the engine. If you need crank the engine too much, the engine no start at the first step, and you need crank and crank and crank, and for some reason the exhaust valves in your engines, the calibration, the valve latch calibration is not proper. Some valves stay a little more time open, especially when the piston is going down during the intake. During the intake, when the piston is going down, what happened with the exhaust valve? The exhaust valve should be closed. What happens if a couple of exhaust valves or one exhaust valve, when the piston is going down during the intake, stay open? What happened in the output? You remember that point? The output of the exhaust manifold, where the salt water converges with the smoke in that point. What happened if you have water over there and during the cranking, one of the pistons with the exhaust valve open suction that salt water? Remember that the suction, the negative pressure when the piston is going down is too high. Yes, this is possible. During the cranking, suction air in the combustion chamber because the valves are bad calibrated. The valve latch calibration is not good. Yes, this is one possibility during the cranking. Other possibility is that the engine is running, but the intercooler is cracked. Remember the function of the intercooler or aftercooler is reduce the temperature of the air before the air fully compressed from the turbo enter in the combustion chamber. What happens if the air coming from the turbo, the temperature is too high? When the air additionally is compressed for the piston, produce vapor lock, and you can destroy the valves. Okay, this is to avoid vapor lock. Okay, this is another possibility. Intercooler crack, and the air at high pressure suction the water crack in the intercooler and enter that water in the combustion chamber. That's other possibility for salt water entering in the combustion chamber. Number one, during the cranking, if the exhaust valves are not calibrated appropriately. Okay, number two is a crack in the intercooler. Number three is water in the fuel. Excessive amount of water in the fuel enter with water, and bad filtration in the water separator filters, and you have humidity in the combustion chamber, and of course you have white smoke. Those are the three possibilities for salt water entering in the combustion chamber. Remember that when salt water enters in the combustion chamber, practically immediately the engine lock. In comparison with when coolant enters in the combustion chamber. When coolant enters in the combustion chamber, of course, at the end of the day, the oil will be milky oil, but the engine continues running with low oil pressure because the coolant damages the properties of the oil and the pressure of the oil decreases dramatically, but the engine continues running. However, when it's salt water entering in the combustion chamber, in a couple of seconds, the engine locks. because of the thermal expansion of dissimilar metals occur in the moment of the explosion with salt water. With salt water, the situation is catastrophic. With a coolant, it's also catastrophic, but the engine can run. You can recover the engine easily if the problem is with the coolant. If the problem is with salt water, it's difficult. Okay, other possibility for water entering in the combustion chamber, in that case the coolant, is a problem on the head. The head is cracked, and the cavities where the coolant circulate, the coolant penetrate and enter in the combustion chamber. Other possibility is in the cylinder liners. You remember that there are two types of liners in inboard marine diesel engines, dry liners and wet liners. You remember that slide? The wet liner are surrounded for coolant, and the liners, they have O-rings on top and in the bottom. What happens if those liners are cracked, are perforated for feeding corrosion or erosion in the external wall of the cylinder liner? Yes, the water penetrates and enters in the combustion chamber. Problem with the cylinder liners, that's other possibility. Of course, head gasket damage, this is other possibility. Okay, my friends, those are the possibilities for white smoke, black smoke, and blue smoke. If you enjoy this episode, this video, you want to say thank you, please apply thanks in the option for thanks. I appreciate your contribution. I need your contribution to continue producing material for you. Thank you.